fourth semester in organic chemistry group. Today I am going to give some basic idea to this voice lecture about electron spin resonance or electron paramagnetic resonance spectroscopy. Now, electron resonance spectroscopy is a technique which use spinning properties of electron which are in resonance. How this happen? Let us discuss. As we know from the previous standard that molecule has atom and every atom has a nucleus containing positively charged proton and neutral charged neutron. As a whole, nucleus is positively charged body around which negatively charged electron move. As we know that electron has two properties of rotation, that is one around the nucleus and other one around its own axis, shown in figure 1. Then in other scenes, we can see there are two types of rotation performed by electron, around the nucleus and around its axis. As electron itself spin around its axis while rotating around the nucleus, right? This is the point. And we have noted that when a charged body rotates, it behaves like a magnet and generate magnetic field. Here, we have known that negatively charged electron rotate around its axis and behave character like magnet and generate magnetic field. To understand better, let us see figure 2. An electron rotates around its own axis, behave like a magnet. Then let us come to magnetic property. As we have learned that there are two important magnetic properties of our nature or behavior. One, diamagnetic properties, and paramagnetic properties having odd or unpaired electron. That is, diamagnetic properties means pure electronic environment shown by the species, and the paramagnetic properties means unpaired electronic environment by the molecules or species. Now, let us focus on diamagnetic behavior of the molecule having pure electron. That pair, one electron in the clockwise and other one in anti-clockwise to get the stability. In figure 2, you can see from figure 2. Here, clockwise rotation and its magnetic field pointing up, while the anti-clockwise rotation and its magnetic field pointing down. As we have this from the point, we can see anti-parallel to each other in their magnetic field due to the opposite direction. And the magnetic field generated by both two electrons get cancel each other. Now, to explain the rotation of an electron around its own axis, we use a special term known as electron spin quantum number, denoted by ms. Electron rotating clockwise direction is denoted by ms value plus half, and the that of anti-clockwise is denoted by ms value minus half. Here, for a diamagnetic substance, ms value is plus half and minus half. That is, ms value is plus and minus half. That is, self-cancellation happen. Such kind of magnetic behavior is known as dimagnetic behavior. In figure 4, you can see from figure 4. Now let us discuss about the paramagnetic nature of the substance having odd or unpaired electron, that is single electron. That this single or electron may rotate either clockwise or anti-clockwise. As shown in the figure 5, only one electron, maybe in the clockwise or anti-clockwise, or electron spin quantum number, maybe plus half or minus half, depending on the rotation. Such kind of magnetic nature of behavior is known as paramagnetic nature. Some common example: iron, cobalt, nickel, free radical, and also triplet state. The magnetic, that is the paramagnetic nature of this element or species, is known as ferromagnetism. From this, we can say that in ESR, means electron spin resonance, only paramagnetic molecule or species or sample is used, since it attracts the magnetic field applied. That is, attraction occurs between the applied field with the paramagnetic substance. Now let us see how this paramagnetic behavior is used in the working or function of ESR. For this, we have to know ESR chamber. As shown in the figure 6 and 7, you can see in the ESR chamber, one magnet present. From this magnet, magnetic field generated around 50 to 500 millitesla strength, or 3400 Gauss. The field generated is known as applied magnetic field. And when we put a substance containing unpaired electron, and suppose its rotation is anti-clockwise direction, the direction of the applied magnetic field is changed, shown in the figure 6. In changes of, due to this applied magnetic field, the direction of the magnetic field of the spinning electron are in the same direction, that is parallel, aligned or parallel. That is the field of the magnetic field produced from the ESR and the that of the revolving or rotating electron are in the same direction. That is, this is known as parallel state, or also known as alpha state, having the lower inertia. And the next step, if we provide some energy to the alpha state in the form of radiation of microwave region, having the wavelength 3 centimeter or 9 Gus, this energy supply change the direction of the electron spin opposite to the applied field, shown in the figure 7. That is alpha to beta or beta to alpha, depending on the direction present. Such condition is known as beta state or anti-parallel state. That is the field direction in magnetic field produced by the ESR chamber and the that of the electron are in the opposite direction. Such condition is known as anti-parallel or beta state, having the higher inertia. Now, we can conclude some idea. Electron absorb energy in the microwave region and the change alpha to beta or vice versa. That is, changing of the direction of the electron spin takes place alpha to beta or beta to alpha. Such condition is known as resonance. Oh, you can see the resonance shown by electron of spinning motion is known as electron spin resonance. And the technique which is used to study the electronic motion or rotation is known as ESR spectroscopy. Here, if we blow or cut the source of the radiation, that is the microwave radiation applied, then shifted to alpha, beta to alpha due to the microwave, and after removing the microwave, return to the again to the original mode, to the initial state. Such from this we have the idea of the alpha or beta, or alpha to beta or beta to alpha due to the microwave is known as the ESR technique, and only paramagnetic substance or species get attracted by the applied magnetic field that is produced by the ESR is known as EPR, because E means electron paramagnetic resonance spectroscopy. Here the paramagnetic substance get attracted by the ESR chamber. Now you can notate some few important. Microwave radiation is generally produced by the classical oscillator, and most of the sample under study should be solid state, and the reference or standard sample generally diphenyl picryl hydrazine DPPH. Okay, up to this, try to understand. If you have any difficulty, you can contact to me. Okay, thank you, my dear student. Have a good day. My dear MAC 4